So since we didn't finish the notes today in class, I wanted to go over examples like the last ones that you'll see on the homework for tonight, just to kind of get you guys started on questions that look like this. So for each of the following functions, for example, one, we want to explain the horizontal and vertical transformations, direction and units of the parent function, the absolute value of x. We want to identify the slope of each branch of the graph and then identify the vertex of the transformed graph. So the first thing I like to do with these types of problems is actually identify what A, H, and K are. So I'll start by saying A is -2, H would be +3, and K would be +4. So kind of from the summary that we put together at the end of class, I should be able to identify what the shift left or right is and the shift up or down is pretty easily. So I will start with the horizontal shift, and that means movement left or right. So since the H value is positive, that means that our horizontal shift is going to be right. So the way that I usually write that is 3 units to the right. And then the vertical shift is really talking about is the movement up or down. So we know that that has to do with the K value. So since the K value is positive, we're going to say that it's moving up. So vertical shift, we're going to say 4 units up. And then I want to also talk about the A value. So from my other video and from what we talked about in class, we know that the A value is negative and it is a 2. So there's two things that are happening here with the transformation. So there is a reflection over the x-axis, and that's because A is negative. And then since the A value is a +2, we saw that kind of in an example in class today that we graphed together. That means that there's also going to be a vertical stretch. So the graph is going to be a little bit narrower than the parent graph. So I'm going to say vertical stretch. And usually when we talk about the vertical stretch, we want to say by how much. So we say vertical stretch by a factor of. And again, the negative only has to do with the reflection. So when I talk about the factor of, I'm really only going to be concentrating on the 2. So vertical stretch by a factor of 2. And again, that has to do with our A value. So horizontal shift, that's our H value. Vertical shift, that's our K value. And then the reflection, the vertical stretch or shrink is going to be the A value. So then we also want to talk about its vertex. So in class, we talked about how the vertex is always the H comma K. So even though I don't know what the graph looks like, I know that its vertex is located at 3, 4. And again, that's because our parent vertex is at 0, 0. So we're moving to the right 3 units and we're moving up 4 units. And then the last thing that we want to talk about is the slope. So we want to take the slope of the right branch and the left branch. And we kind of made a little bit of a connection to the slope and the A value. So the slope is actually always going to be the A value, and that's going to be the slope of the right branch. So since our A value here is -2, that's going to be the slope of my right branch of my graph. And the slope of the left branch is also going to be 2, but it's going to be a +2 because we said that they kind of always come in pairs. One's going to be negative, one's going to be positive. It just depends on which way the graph is actually going to be facing. All right, so we'll go through the next one quickly. I'll kind of work my way down, so I'm not going to rewrite all this stuff here. I'll say this is going to be HS, that's horizontal shift. So here our A value for example B is 1/3. Our H value is -1. Our K value is -2. And again, be careful here because that it's really an X minus -1 in the absolute value bars there. So our horizontal shift, since our H value is negative, we're going to be moving to the left 1 unit. And it's 1 because our H value is 1. Our vertical shift, we are moving down since K is negative. So I'm going to say we're moving down 2 units. Here, our next thing was the reflection. Since our A value was negative over here in example A, we had a reflection, but since our A value here is positive in example B, there's actually no reflection. And that's because A is positive. And here we actually have a fraction value. So this is kind of like the example that I went over and posted the video before this one. When we have a fraction that's in between 0 and 1, this is actually going to be a vertical shrink. So this is what happens when the graph gets wider than the parent graph. So we say it's going to be a vertical shrink. And again, I'm going to use the wording that it did on the last one. So by a factor of, and I'm just going to say 1/3. So when your a value is some sort of whole number, or well, it could be a fraction, but as long as it's over 1, there's going to be a vertical stretch. And then the vertical shrink happens when it's going to be somewhere between 0 and 1. And again, the negative over here only has to do with the reflection. It has nothing to do with the stretch or the shrink. So then I can identify my vertex. My vertex here is h comma k, so -1 comma -2. And then we can talk about the slope. So right branch and left branch. So since my a value here is 1/3, that's going to be the slope of my right branch. And my left branch is also going to have a slope of 1/3, but the left branch is going to be negative. All right, so example 2 and 3 are kind of similar to each other. We didn't necessarily talk about this in class, but I just want to make the connection of the a, h, and k. So we want to determine the absolute value function that's obtained from the parent function y is equal to the absolute value of x after the sequence of transformations. So basically what I'm going to do here is I'm going to go through and identify what value this has to do with. Is it a, is it h, is it k? And then we can actually take our standard form of our equation and then just kind of plug in things that we know to make a new standard form of an equation. So we're talking about a vertical shrink by a factor of 1/4. That's telling us that this has to do with our a value. So this is telling us that our a value is 1/4. So shrink or stretch always has to do with a. Vertical translation 1 unit up, that's telling us that our k value is positive. And if we're moving 1 unit, k value is +1. Horizontal translation 3 units to the left, that has to do with our h value. And if we're moving to the left, that means that h is negative. And if we're moving 3 units, that tells us h is -3. So when I use the standard form of the equation, f of x is equal to a times the absolute value of x minus h plus k, and I have all this information, I'm just going to drop them into their places here. And then I'm going to clean up my equation a little bit. So f of x is going to be equal to a is 1/4 times the absolute value of x minus h is -3, plus k is 1. So the only thing that I want to fix here is that I never want to leave a double negative on the inside here. So if I want to write this in completely kind of standard form, I would rewrite this as f of x equal to 1/4 times the absolute value of x plus 3 and then plus 1. So when it's asking you to determine a function, it's really just asking you to write its equation. We don't have to do anything with this. We're just kind of pulling that information from here and then dropping it in its place and just simplifying. All right, last example, we're pretty much doing the same thing. This one's a little bit different. So we're still looking for a function that's moved from the parent function y is equal to the absolute value of x. This time we're given 4 things here. We know we have a reflection across the x-axis. This is telling us that the a value is negative. So anytime we're talking about a reflection, your a value is going to be negative. A vertical stretch by a factor of 1.25. So when we're talking about a stretch, we know that that value is going to be more than 1, which it is, 1.25. But when we write our actual function, we generally like to keep things in terms of fractions. So this one up here was 1/3, this one down here was 1/4. So what I'm going to do is I'm actually going to rewrite this 1.25 to be an improper fraction. And I know that the stretch has to do with the a value. So this is telling me that a is 1.25. So if I write that as an improper fraction, that'll be 5/4. So these two things together are really telling us that when we plug into our standard form of our equation, what we want to use is an a value of -5/4. And then we're looking at a horizontal translation 6 units to the left. Again, horizontal has to do with the h value. And if we're moving to the left, we're moving in the negative direction, so -6. And then vertical translation 3 units down. Vertical, we're talking about k. If we're moving down, k is negative, and it's going to be a negative since we're moving 3 units down. So if I drop this all into my standard form, this is going to tell us that my function is going to be -5/4 times the absolute value of x minus -6, and then -3. And again, I'm just going to clean up on the inside of those absolute value bars just to make that a positive. So f of x would be equal to -5/4 times the absolute value of x plus 6, and then -3. And that would be my function. All right, so hopefully this helps on your homework. Please let me know if you have any other questions.